Let's see. I wonder if this is gonna take out the stream, but we'll see. I would much rather it use my wired connection than wireless. Still good? Alright. Kill some stuff. Okay, cool. So I actually did a stream maybe a week ago where I tried to get started with the Daisy from Electrosmith. Let me bring that up on the screen. Let's see. Yeah. So anyways, and I was using this as kind of an excuse to, I have the pod, as an excuse to kind of to get into C programming and C++ programming, real-time programming, audio programming, all of these above. But the audio crapped out on the stream last week, and so it was silent the entire time. But this week, the audio is better, so... Or the audio will be working. And not only that, I ran into some snags that I had to fix off stream anyways with the Daisy. It wasn't a problem with the Daisy, it was a problem with my USB cable. So if you're here because you are also a Daisy user and maybe you've run into it not working, well, try swapping out your cable. Okay, so and what I have on it currently, and I don't have a camera on the Daisy right now, but I have the LED, so let me see, let me bring up the web programmer. Daisy. This is not it. This guy. There you go. Okay. So I was having problems before that it wasn't showing up in my list here, and it's not showing up now currently because I don't have it in DFU or programming mode, but let me just hit the boot and then reset button, and then hopefully this guy will show up in there now. And you do, DFU and FS mode. So hit connect to that. It's connected to my Daisy. I have the pod, and so I just loaded simple LED. So let's take a look at simple LED. So, well, let's see. Right. So, and this is basically controlling the red or the green, so you can, of the LED. And so, as you twist these, this guy changes. This LED changes colors. But let's read this. Bin pod simple LED. Okay. So one of the other things that I did is I went ahead and cloned down the Daisy examples, which we have here. So let me open this in Vim. Okay. Pod. Got our examples, simple LED. So one of the things that I would like to do is instead of loading it with loading it through the web programmer, I would like to just load it here, right? So I think load it through the command line, sorry, that wasn't the clearest. So let's take a look at what the simple LED does. Okay, so this is going to be our hex files, yep. So I have built in here. Let's take a look at the make file. Alright, so the make file, yeah, is just going to basically use a parent or Makefile. Okay. So this is something that I'm super interested in that I don't know anything about. So GDB or VGBD, VGDB is a remote debugger. I know GBD is. The DB stands for debugger. I'm not sure about the rest. So I am super interested. Visual remote debugger. I don't know what the G stands for. But I am interested in doing some remote debugging. Not now, but maybe later. Well, this is interesting. There's a Visual Studio. Cool. Sometimes you can get some information out of these for how to build. This doesn't, it's kind of speaking Greek to me. It looks like it reaches out. I don't know what a VCX project is. Looks like something Microsoft related. Anyways. So this is another thing. This seems to be STM related. Was generated by Visual G. Contains GCC. Interesting. Okay. So this is something the compiler wrote out. This project managing. Right, so this is something that the compiler wrote out to pass along possibly to the microcontroller. And then let's see, this guy. Okay. Now this is okay. This is good stuff to know. What version of GCC? What version of GDB for when we eventually use that? Looks like a namespace there. It looks like a Java namespace. But MCU, Master Control Unit, if Tron has taught me anything. Alright, but this looks like it points to an XML file that I'm sure STM32 has defined for the onboard STM32 chip, which is going to be this H7. Okay. So I'm just exploring around, just reading, figuring out. Most of this is Greek to me. I don't understand exactly what a lot of it is, but just getting a feel for it, for what modern embedded programming looks like. Okay, let's take a look at the README. Yep. Code snippet. Yeah, this looks cool. Yep, there's the diagram. Okay, cool. So let's take a look at the code. Here we go. The code. Oh! Come on, guys. Leaving some dangling white space. Uh-oh. Who did that? Oh, Ulti-Snips is complaining. Right, you're having problems finding Python. Everybody's having problems finding Python. That's going to be a problem. I might have to turn Ulti-Snips off. Yeah, we'll come back to that. Okay. Because it might be every time, yeah, I enter in exit mode. Let me do that real quick. That's fine. Okay, maybe I'll stop complaining. Nope, not gonna stop complaining. Alright. Okay, So here we go, Daisy Pod. So who is Daisy Pod? Let's go up a directory. Looking for Daisy Pod. Who defined Daisy Pod? Alright, so let's do a grep. No good, no bueno. So, let me see what my... There we go. So everybody define or includes Daisy Pod. Well, who defines it though? Okay, let's not get bogged down in that. I bet you it's in that lib, and one of these guys, lib Daisy. Let's see if we can find it real quick. Get distracted. Why not? Alright. I can do this as a grep. See if this works. Okay, so it's in lib. Okay, yeah, there we go. Boom, this guy. Okay, so there must be, you know what, I bet you that's a part of the compiler. So if we go and take a look at, so here's what I'm thinking, is like anytime you don't see a namespace from this, then it's got to know, so this include is like, you know, an import. And so it's got to be somewhere on the file system, and I'm trying to figure out where is this on the file system. And normally you'll have either like a relative path or something like that that'll point to you. Otherwise it has to be in the same folder. It wasn't in the same folder, so there has to be an alias somewhere set pointing at this. And so my guess is, and I'm pretty confident about this because I don't know where else it's got to come from somewhere, and it's got to come from the makefile. And so what I suspect is happening now, there's probably a lot of things in the parent makefile, which is this guy, that are going on that are, I mean, this is like pretty opaque to me. I have no idea what's happening in the make. So, but if I had to guess, setting these variables is at compile time that the core libraries are loaded into the path, if you will, so that way whenever we do an include, it will check the path as well as the current directory for this file before trying to read it. And so libdaisy, yeah, there's probably gonna be a lot of things in here. Oh, there's so many good things in here. I want to check out the UART wave player, GPIO, I2C. So many interesting things I'm trying to learn more about, but we'll trying to start simple. So dep is not, I don't know what a dep is actually. Here we go. So this guy, yep. So yeah, this is gonna define all of the hardware or the memory locations for, I guess, when the GPIO of the Daisy and how it interfaces with, I don't know who's the daughter board. Would it be the pod or the Daisy? But these are the GPIO that the hardware, like the circuit of the GPIO on the hardware for the Daisy is going to eventually make its way to an LED button, line out, whatever. And so these are definitions for those mappings. So just reading around in here. looks like just some static functions being defined. I wonder when and if this gets called as a part of our program, because it has to be. So if we come down here, take a look at simple LED. Let's see. Right, so I wonder, so we're defining a Daisy pod, which is called, I guess an instance of the Daisy pod is HW. Where else are you? Yeah, okay. Okay, so that's where it gets called, right here. Okay. So hardware, let's see, hardware knob 1. Knob 1, but you got to be defined somewhere. Nope. Init knobs, so knobs, knob 1. Get knob value. Yeah, I wish you guys had a better. Oh, here we go, knob 1. So I'm assuming that there's going to be another. There we go, yeah. Init single. Interesting. See, get pin. So what's init single do? That must come from. So what is knob init? Is an ADC channel config. Okay. So ADC stands for analog to digital converter. So that is, you know, the outside world coming into the digital world, which is a knob, right? That's going to be resistance or current, voltage, and then we have to convert that to our bits. So now knob init, are you defined? Knob init is not defined. Knob blast. Knob blast, that doesn't help. Okay. I don't know, maybe, and then maybe this is an implementation detail of C where you, this is knob init is defined as, I don't know what this is actually. I can make a guess, but you know, it's obviously it's either an array or like a hash table or something. This is, I mean, and this is exactly why I'm here. These are the kind of things that I want to know, like the subtleties of C. Right? This is probably pretty simple code to be able to read for a C programmer, but as a JavaScript programmer, I need to know these things. Knob blast has got to be some, so being all uppercase, it's got to be some sort of a static. It's like going to be a number or something like that. So I don't know who defines it. This file doesn't find it. That's kind of one of the opaque things about C, is it could be defined in daisypod.h. You know what? Let's open up. Come on, daisypod.h. Where are you? I betcha class. Oh, that's right. This is C++. This isn't C. Okay, cool. Knob blast. Here we go. Knob 1 and knob 2. Here we go. Enum, part of this. That's all. That's cool. Aye. But these should all be scoped to a class instance, right? Maybe. Is this like, so this is probably going to be like the abstract base class. Class handles the initialization of all the hardware specific helper functions, built-in controls, and peripherals. Okay, I mean, cool. So namespace Daisy, Daisy pod, public. So I wonder, so start audio, I wonder if that exists in our Daisy pod down here. It does, okay. So I think this is an abstract base class where it's defining the interfaces for what is going to be on the instances of this class, and then this is the actual implementation of those. It's kind of weird to me because, you know, I'm used to, like, you have a new keyword, right? And so when you want to create an instance of class, you have a constructor, but it seems like that those assumptions or heuristics aren't here in C++, or this is a pattern that they use where this looks like a constructor to me, and so as a part of the class definition you don't define a constructor. And maybe this is a implementation or a detail about, you know, what you can and can't do in H files. I'm not sure what you can or can't do in H files. Huh. Okay. All these are public. Cool. Putting it in a coder. Yeah. I wonder if init buttons comes from somewhere else. Like, who defines init buttons? Oh, there it is. We define init buttons. This is very object-oriented. Very object-oriented. Anyways. Okay, cool. So, kind of going back to our code here. So this initializes the board, and which this does a lot of the Daisy stuff. Cool, cool, cool. P underscore. Okay, parameter knob1, knob2. I wonder who defines parameter. Oh. We do? Huh. Probably comes from the parent lib. I'm gonna have to get my uCompleteMe working so that way I can just do a go-to definition. Yeah. Yeah, YCM is not playing nice. I'll get that working. Okay. So this is our loop, red and green. So if we wanted to, we could actually change one of these to blue, right? Where's B? Is B static? Oh, blue is 0, right? So if we wanted to be clever, let's just change this to blue. So now, what are you complaining about? Why? Oh, whatever. I gotta figure out how to get my development environment up and running. Okay. So basically now, whenever I turn knob 2, it should add blue to it. So let's compile this and let's get this on the board. Prove out the pipeline. Here we are, Daisy examples. Let's go into pod. And what's a simple LED? Isn't there's like, it's like you can do like DFU program or make DFU program. Hang on. And actually, I think I'm gonna have to disconnect. Yeah. Which is fine. I think this is it, but I want to make program DFU. Okay. Oh God. And I think I remember somebody saying that it says that there's an error every time. Now, how did it know which USB device? Uh-oh. Did I just blow out something else? No, it wouldn't have been in boot mode. Okay. So, one of these guys, babyface, hub, whatever. But let's see, so it wrote to DF11. There is no DF11 on here. Huh. But it, well, even though it's not in LSUSB, it does appear that... Oh, you know what? I didn't compile. So right now, you can't see it, but I'm twisting it, and the right one is adjusting the green color, and we want, and so we specifically changed it to change the blue color. So let's so it didn't build. I think it just wrote like a pre-existing, yeah, build simple LED. So why don't let's just do a make. Let's try make build. Make. Okay, it looks like it wrote some new hexes. So let's do DFU program. Okay. So it doesn't look, it looks like I need to put it back in bootloader mode, so let's do that. Or flash mode, I don't know what to call it. So, there we go. Okay. Yep. And you can't see it, but the right, now we have blue and purple, now it's purple and yellow, and it's all the different colors. So cool. That is how you make a change and send it off. Man, I know way less about C++ and C than I thought I did. There are some subtleties here that I am a total noob on. This pattern does seem strange to me, but it's just very like the pattern of having the class definition in the H file, and then I guess that's an abstract base class. Yeah, I don't know. I have to read up on some C, how C++ classes work. Let's do that now. I'm sure this is going to come up with like some education stuff. Clicking on the first thing, if it's W3 schools, whatever. Sure. Method to access data members, it's fine. Okay, so you can, it's not a .h thing. And it looks like they just went ahead and just added in the there are two ways to define a member function: inside the class definition, outside. So, right, okay, so outside. So here's what we saw, where this was in the .h file, and then this was in the CPP file. So they do have constructors. Why didn't they use constructors? Whatever. I'm sure they have reasons for they're much better C++ programmers than me. I'm sure they have reasons. Huh. Okay, well that explains a lot of that. Let's go take a look. What else do we have in the pod examples? Actually, I'm super interested in Looper, so we're going to look at the Looper. This might be well and way over my head, but I do want to try it out. Oh my god, this is like brown M&Ms or green M&Ms for me. Like, keep your... Come on. You know what? I think I can just... No, not the whole file, please. Okay. Whatever, I'll take it. Okay. So audio callback, cool. It's a good thing to know. Or this is gonna get called at some sort of looping interval. I'm much more familiar with callbacks than, I guess, like while one loops. So I like, this makes me feel comfortable. Next sample. I guess this is a function. Okay, let me start at the top. All right. Pod. Initializing some variables. DaisySD RAM BSS. Is that a bus? I don't know. Okay. Oscillator, DaisyDSP module. Okay, okay. 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 Oh, okay. So I bet you the audio callback. If you notice here, we don't use the while loop. I mean, we do. I guess that has to be defined for some reason. But this guy does the bulk of the loop engine, I guess. Audio engine. And so instead of putting what we want to happen, you know, every cycle or every frame inside of the while loop, we now have inside of this callback, which is just this function. So this looks simple enough. Control, so this is probably going to update the controls. It zeroes out the output, so it'll be silence if nothing touches the output. So here to size, I believe we define, where do we find size? Oh, okay. It's a part here. Okay. It's probably a part of, okay. Without diving off too deep into there. This size is going to get set. It's passed in indirectly through one of these. Okay, anyways, controls, size. +2. Okay. Next samples. Okay. Put an N. Okay. Left and right outputs. Okay. So this has got to be a tuple. No. So we're setting, okay, setting the left and the right outputs to the same thing. So it's a mono signal? I guess it's got to be a mono signal. So that could be a cool thing to update, is make this stereo instead of. I bet you it is. No, it looks like it's a TRS cable. So you should be able to get a stereo signal in and a stereo signal out. So yeah. Reset buffer. So this zeroes out the whole buffer. How often does it get? Okay, this only gets called on init. Yeah, okay, good. So it's just zeroes out the memory. Oh, cool. On key down, right? Yeah, this drives me crazy. Okay. There's some nice little functions in here. Time held and melt. That's useful. That's cool. I'm interested in the implementation of that, but. Just doing some cleanup, reading. Alright. Right buffer. So if you're... Oh, cool! Right. Right. Okay. So this is how... This is how you put stuff from what's coming out from the input here. And you put that into the buffer. Alright, let's see. Let's actually, you know, it's funny, I opened up the C++ file. Let's see what the README says. You know what, I want to look at this in a browser. Which apparently I'm not going to be able to do. Looper. Okay, button 1, play pause, record. Press record, sound on sound. So interesting. Hold to reset. Record enable, green playback. Knob 1, what is knob 1? Knob 1, this guy. Left is in, right is loop. Oh, so this is the mix between the two. Interesting. Oh, how did they do the mix? All right, let's look at the code. Let's see how they did the mix. So if you're not recording this and this, time. Okay, so it's got to be a part of the the output. So audio callback. So it's got to be in this next samples. I don't see where it's. I mean, it's gotta be in here. I gotta. Here we go. So dry, wet. Who are you? Okay. Interesting. So it pulls the dry, wet value off of the button, and then down here. So if you're not recording, this is what you're not recording. You're playing, or stopped, I guess. The output is equal to output times dry, wet. So this, okay, so the input, if we think of this as a voltage coming in, not an AC voltage, let's think of this as a DC voltage. So the output times dry, wet. But the output, if I'm not mistaken, so buffer position, okay. So this is, so this value, the output value, will be whatever is in the current position of the buffer. So what was written in from before. And then times dry, wet. So let's say, not sure what the value is going to be for that. But let's say if that's, oh, okay, so if it's 0, that means it's all the way to the left, right? That is going to 0 these out. And so therefore, it's just going to be the input. Where's I? Okay, I. Okay, right. Times 1 minus, right, so this is, so if dry, wet is 0, then so this would be 1 minus 0, which is 1, so times 1. So, okay, so this is the inverse of dry, wet. Interesting. So you can imagine, let's say it's, this goes to like 0.5, right? So output times 0. So this is going to be half the voltage, half the value. So the amplitude, that's how you take away the amplitude of the output. Is you just cut it in half, and then for this guy, it is also half of the amplitude, like for it. So, right. And so that's how you get a 50% dry, wet mix. Interesting. This is super interesting, super cool. But, so what happens, so if it's recording, does it not, so it's sound on sound, so if it records, if record, right buffer, okay, so that's how it gets into the buffer, and then after it gets into the buffer, next go around, I guess. So I have a feeling mod, this is who is going, yeah, mod equals max size. Somebody is going to be doing the loop around. I have a feeling it's this guy, yeah, position plus plus, and then not entirely mod equals. What is mod equals? That is not helpful at all. Because I feel like this is some sort of like assignment, maybe. So position is like, Like, is this the equivalent to? That's what I'm thinking. Because that'll put the position back at the beginning of the buffer once this increment's over mod. Yeah, because this will be 0. Position would be 0. Like once, you know, once we get to the mod limit, which is going to be the max size, and the max size is going to be our buffer size, right? Which is 5 minutes of 48 kilohertz. Okay. Cool. All right, I'm gonna call it a day there. No one tuned into the stream, not that that matters, but if you're watching this after the fact, hopefully it was interesting. It was mostly me bumbling around in the dark, but I hope to be getting better every day. That's the point of these, or that's the point. So, thank you very much if you watched this and you got this far.